All right, hello everybody, and welcome to Malware Club. Sorry for the delay there. I was just having a little technical difficulties, but I got my recorder started up. Welcome everybody. Today, there's not much announcements, but Evan is going to be presenting on doing like network traffic analysis, and he's going to like present a Python script that he's been writing for one of his projects. And he's just gonna go over like using like Python with malware analysis, I believe. So yeah, I'm just gonna hand it over to Evan.
Sweet, thanks, son. I'm just going to switch over here and share my screen. Can everybody see that okay?
Yep, I could see it.
All right. So yeah, just as Odin said, we're going to be going over using Python to analyze PCAPs today. And just to start us out, we're going to be going over like the HTTP protocol a little bit and using Wireshark just to get a basics. And so what is Wireshark? It is first and foremost a network protocol analyzer. It allows you to see what is happening on the network or on a smallest network capture from the smallest levels of packets and data flying around there. It can be used to troubleshoot network problems, find security issues, debug problems, learn more about networks and their protocols, and more. So parts of a URL here, you'll see that the URL and both URI kind of contain the entire thing, but URL doesn't actually contain the entire string. Sometimes there's some modifiers at the end that the URL doesn't actually contain, and the URI is used to actually contain that full string there. But at the end, you can see they've got that like the file name, and then right before that, the 8 is like a subdirectory, just like a normal path traversal, just like on the computer. Then the .com is a top level domain or TLD. There's a domain name and then the protocol or scheme. So what I'm using it for is, in this instance, viewing HTTP packets in Python and the related data to them. So in Wireshark, you're able to filter for tons of different things, and one of those things is by protocol. Up in the left-hand corner, you can see HTTP. I could even specify that more with further rules, but in filters and expressions, but here, like I could use HTTP requests and get even more information. But you can see on the, we've got the protocol, which is just strictly HTTP. And the first packet there, number 6, is the GET request, which is getting chickadee.php. And the, sorry about that. The response to that is the 301 code, which is moved permanently. And it proceeds to go and try and get another like WordPress content plugin, chickadee.php from over there. And it gets a 200 code. So that was A-OK. Later on, though, you'll see that it gets the favicon.ico, which I'm sure most of you guys know that the favicon is like when you've got your tabs, it's that little icon at the top that kind of represents that tab for the website. And then later on, we've got that, the post information down there, which is the /8/forum.php. So viewing HTTP requests in Python is actually really easy. And this could potentially help you even with some of your classes because they'll require you to find like web addresses and a packet capture and stuff like that. And this is a really quick and easy way to list all of them at once. So you'll just, and I use Mac, but this is the same on Windows as well. Go to the statistics area, down to HTTP, and go over to requests, and then you'll see a huge list of them. So over here, we've got ones like mamabearcoffee.com, and then after that, we've got the following information below it, like the WordPress content and favicon ICO that was gotten through it. And then lower than that, we've got the formorpont.ru, which is getting the 41s.bin and 41.bin. And even lower than that, we've got just the IP addresses, which have things like the submit.php for both of them, which is a little suspicious as well. So here in this GET request, you'll see that it's getting the 41s.bin and then lower 41.bin. And .bin is a pretty popular extension for malicious files, just so you don't like accidentally execute them. Technically, you could use anything because it doesn't really like symbolize any specific file extension. but .bin is just like industry standard for those malicious files. And so before you see this, so like right over here on the right-hand side, you'll see those blue and red colors. But blue and red in Wireshark, the blue represents server to client traffic and the red represents client to server traffic. So following this stream, you'll see on the left side, you just have to right click one of the packets, go down to follow, and then HTTP stream. And you'll see that there's a GET request over to the 41s.bin, and that's on that formarpont.ru address. And it responds back with just completely unreadable information. And unreadable information in and of itself isn't naturally immediately a suspicious thing. If it's getting like a .bin file and you immediately see at the top, like the first packet, like this is an MZ file, like that's extremely suspicious because it's just an exe trying to hide itself. But here, this could be really any data that's like encoded or any program or anything, but it's definitely that 41S bins data. And so following that stream, those streams further, we'll see in that post request that went to the forum.php that the host is forkaneller.com, but within it is things like the GUID, the name of the computer, the domain, and the user's username, and then even the IP address for that user, which looks like that's the public IP address for them. And then it responds with data in base64. And going further, there's another submission, another post request that posts the same data, and it is a different base64 response. So that's a pretty clear indicator there. And so this is a representation of data exfiltration. So this is the pure HTML form URL encoded in a little more of an easier format to read, though. So laid out like this, it's really easy to see that it was sending data out about the computer that was on. So performing like domain recon and that data exfil. Then having a little more of that post request is, so it's posting to a just regular IP address with no reply other than a 200 success. And so what is beaconing is one of the first network related indications of a botnet or infection. And after the malware infects the computer, it initiates contact with a C2 server. The beaconing is the malware communicating to the C2. The malware is asking for instructions, checking in, exfiltrating data, and more. So frequency, how it checks it, what protocols are used, and more can vary just malware to malware, whatever the authors intend. So that send out to the host the random IP address, essentially with the like get PTGA, could potentially be some form of beaconing just to check into that C2 server, since there's no response other than the like 200 okay. And this is an example of viewing it in Wireshark. So you'll just see these repetitive packets, the repetitive gets over and over and over again. And then some things aren't quite what they seem. So that favicon.ico, normally that's not going to be suspicious at all to anyone because almost every website these days has a favicon. And then even down there, you can see that it was stored in like WordPress content, plugins, the CSS folder, which is perfectly normal space to like store images that are going to be regularly showing up on a website. But some ICO files have been found to contain malicious PHP code within them, among other things. So if it can contain malicious PHP code, it can almost contain any malicious code if it's just encoded within the file itself. And then looking at, like right before it got that favicon.ico, when it was trying to get the chickadee.php, it has that script tag at the end. And it refers to a onedrive.live.com link that's got like the download key and the authorization to download it. So it looks like it's a private OneDrive link. But OneDrive for a while now, they're just really being called out on it now, has been a big spot to store malware just because it's so easy. So instead of having to hack into somebody's like random WordPress site and like try and store your files within theirs for as long as you possibly can, they can just create a free Microsoft account, sign up for OneDrive, get their like free 5 gigabytes or whatever it is, and store their malware publicly to get given. So when it gets taken down, they can just create a new account, throw another piece of malware up there. And then if you actually see on the refer, it is from that chickadee.php. So the chickadee.php was successfully brought down. So after it was successfully downloaded to the computer, it moved on to download the favicon.ico. And Google is your friend in these situations. So just Googling the domain name and malware. I use malware, but you can usually just Google the domain name, but I just use it to narrow down results. It immediately pops up with like the exact URL that's actually mentioned in Wireshark, which is that /wp content /plugins. And then below that, it even tells about the type of malware that's being used there. So there's Chanceter, which is another iteration of Hanceter. So now we can get a little bit more into Python. And I will preface this by saying, like, I'm a complete noob when it comes to Python. So me being able to write this means that better programmers can write almost anything in the language. So why is Python useful and what is it used for? It's used for data analysis, automation, website development, data visualization, and more. It can essentially be used for anything you really want it to. It's extremely easy to learn and encourages people new to programming to use it. Many people who aren't computer science or cyber are using it, like accountants, scientists, political scientists. It's extremely versatile and it can be used on Windows, Mac, and Linux. Mac and Linux are the only operating systems, I think, where it's default unless Windows changed something. But so like there is like Python malware that exists out there, but it's more prevalent among Mac and Linux because once they download it, it can automatically run. But with Windows, you kind of have to install an entire like environment for it actually to be able to run. Then there's tons of different libraries accessible there, and it's easy to throw together like quick little prototypes if you need it for something. So what is a Python library? Libraries are a set of useful functions that can make it so that a user doesn't have to rewrite code or functions from scratch. They also make it easier to new people who may not have the programming skill to create a certain subset of functions. And so currently there's 137,000 publicly available Python libraries available today. And actually, just like on the topic of the libraries, a lot of you guys probably have already taken like assembly and stuff like that. And I know one of the popular assignments in that class is rewriting like the printf function. So that function in and of itself could kind of be an example of like a larger usage of a library or something like that. So examples of popular Python libraries are things like requests, which is an HTTP library for Python. And the goal of it is to make HTTP requests simpler and more human-friendly to use. If you've ever like looked at like a C program that's used by like C2 to handle like beaconing or anything like that, it is a nightmare to look at. But it can also pass parameters and URLs, send custom headers and more. So you can even utilize requests to like maybe automate testing out web applications against certain like exploits. And then there's Scapy, which is a packet manipulation program. It can forge or decode packets of a wide number of protocols and can capture packets and also do like things like probing and trace routing. And then there's NumPy, which is extremely fundamental currently for scientific computing with Python, and it adds support for extremely large multi-dimensional arrays and matrices. It has high mathematical functions to use on those arrays as well. And can Python be used for malware analysis? Yes. Tons of popular scripts have been written. These are just a couple of them. OllyDump, which is used to analyze Olly files like Word documents and Excel spreadsheets. Then there's ViperMonkey, which is VBA emulation, which can be used on the same. Then Pepper is static analysis on PE files. So think of kind of like PE Bear, PE Studio. Then there's R2Pipe, which is a Python API for Radar2, which Radar2 is a disassembler, kind of like Ghidra, and it's free and open source. So this comes down to analyzing PCAPs with Python, which is what I chose to do my project this semester on in one of my master's classes. I utilized several libraries, but the main ones that I used were the dpacket library and the RE library. The dpacket library is used for fast and simple packet creation and parsing and has definitions for basic TCP and IP protocols and is used as the backbone of my first module to parse the packets themselves. Then the RE library is a regular expression operations, and regex is a sequence of characters that specifies a search pattern. And this library allows a user to use regex in Python easily. So it's used to look for patterns in packets like IP addresses, URLs, and more. You can use it for anything, but I specifically use it to look for those patterns in the packets. And what is a PCAP? A PCAP is just a packet capture file and has a recorded packet data on it that was pulled from the network. Oh, there we go. So opening and reading the PCAP, I'm not going to step through every line of my Python file because I'm pretty sure you guys would just like go to sleep on me. But initially you just have to, it opens up the file and immediately assigns it to like the dpacket PCAP reader. So just shoving that file in there, and then uses a for loop to actually go through the buffer utilizing timestamps in that packet capture. And so along the way, it will assign things like the Ethernet data to the IP, and then the IP data itself to the TCP. So it's just kind of like cutting off the top layers until we get to the specific layer that we want to be at, which at the second circle, it's the TCP data. And then at the third one, which is the contents of the HTTP request, it parses through the TCP's then assigned data and assigns it to request. So each loop through there is one packet essentially. And so that request on like the first loop will show the very first packet of a PCAP capture. And those are those two important variables that I described to you. And so catching HTTP packets though is pretty easy. Repr returns a printable representation string of the given object. So Python sometimes can use different objects to handle things, and there's tons of different data types, especially if you're importing libraries and using those specific data types that they initiate. And that's one of the things that happens with dpacket. So getting it back to kind of like a readable string is what repr is doing here, and then assigning it to HTTP request. And HTTP request is what the first module like leans itself on, being able to human read each packet data. And then, yeah, it's every for loop, it's assigning over like the IP source, as you can see from each individual packet, because there's the IP source, the IP destination of each packet, protocol used, and tons of other different information. And so there's one long list right there that's being shoved in there, and it will eventually be sorted out so that there's no duplicates. Then there's some of the regex use, which can be seen here, the re.search, which is in that link host information. It's searching it for the host info on the packet and the URI info on the packet. So you can see that it starts with the parentheses and ends with the parentheses here. It's basically looking for a single match within, and it's extremely lazy regex. I'm not very good at it. And so the regex, this requires at least one character match. It is described as non-greedy or lazy, and as you can see, it isn't very strict. So with formatting values, you can see that searching this variable each time because of that for loop. And so it looks through each packet for that individual thing. And then once it matches, so it's like if it's a successful match from the research, it will format that into a group and assign it into that variable. And formats the specified values and then inserts them inside of a string placeholder, and group is part of the regex library, and it returns a tuple, which is a finite ordered list containing all of the subgroups of the match. And when importing C, I'm pretty used to just like being able to import them and use whatever functions I want from those imports. But here you actually have to make sure if the minute you import a library at the top of a Python file, like if you have a main and you're importing one of your own files, it will run it immediately. So you need to make sure that like everything inside of that module is within a function, and that you have this little string at the end of it to ensure that it doesn't run without being called from main. And so these are some of the packet examples that were printed in Python. And can you guys see those okay? I try to make them slightly bigger, but so like that first one, you can see it's a post request, and the URI info is a /8/form.php. And then at the end, we even have that information that they tried to pass part, which is that data exfiltration with the like computer name, domain name, and username. And it's even got the host over there, which is forkaneller.com. And further down there, we've got that GET request that did the PTJ and the 139 address. And so that's the potential beaconing address. And this is the final table output from all of that. And up here, we've got the IP sources, which it's just one IP because this PCAP came from malware traffic analysis. And I'm pretty sure that guy's running it just like in its own like isolated little area. So it would only have like one IP source traveling across the network. But then those are all of the IP destinations. And as you can see, some of these aren't like malicious at all. It's just like Windows updates, identity trust things, Google feed proxy. And then over here is IP information, which was looking for that data exfiltration area. And so that's passed within a packet, as you guys saw earlier. And so then we've also got full link information over here. I apologize for how my table looks. The console wasn't having it that day, and some of these links are a little too long and they screwed up the formatting. And then here's just a short little demo video. Just to show how quickly like Python can actually go through all that information. It's crazy. And I'll explain different parts of this automation afterwards. But as you can see, it's using this tweetioc.com site to look at URLs and IPs. It's missing a lot of features that I want, but so far these are a few of the ones that I've implemented. A lot of malware researchers actually put all of their findings and suspicious like URLs, indicators of compromise on Twitter. So that's some of the fastest way to find like up-to-date information on that kind of stuff, other than following like direct threat intelligence feeds, which sometimes can cost like a lot of money to be completely up to date. And then this is the other one it will go through, which is Alien Vault, which shows like a bunch of different things like pulses, URLs referred to, if the file's malicious, if like the URL, IP, and potentially even file hosted there is malicious or not, or has been spotted or in the wild. As you can see, like one of those verdicts was suspicious and then another suspicious. And it even includes links to things like virus total there and who is information. So as you can see here, that's where at the top here where you see the green is where the tweet IOC was doing its work. In this Python script, I used a library called Selenium, which can be used to automate things on your like on Google Chrome or Firefox or anything like that on internet browsers. And this so that allows you to like essentially do anything you normally would. So you can click on certain elements and then grab text from certain elements and store it in variables, or even send like keystrokes and stuff like that. And so it matches on the first table entry and prints it out, saves it and prints it out. And so you could see there that different people successfully posted about different URLs that were picked up from that PCAP and sent across to Tweet IOC. So that x1.c.ncr.org showed up in some piece of malware that was published. And then even further down, you can see the Alien Vault indications, which show like passive DNS hits, URL hits, the pulses, and the file hits there. And then as it scrolls up, you'll see even more information. And so even here, we can see that forkandler.com had a successful hit there for the exact full link, which was the /8/form.php as being used for like a C2 server. And then even up here, we've got another hit which successfully IDs the malware that is present in the PCAP, which is Hanseter. So things that I would do differently for this is I would actually learn Python in the correct syntax and ways it can be used and like the clean coding strategies it has. This was my very first Python program, and up until this point, I had ever coded. I had only coded in C and C sharp a little bit. So I'd basically done like what everybody else in like undergrad cyber operations has touched. And then I'd also figure out how to like implement the ability to handle other protocols like DNS, HTTPS, and more. I don't think it would be too hard, but I just haven't had that much time to work on it as it's just one of my many projects for other classes. And then I'd like to implement some more features surrounding checking other threat intelligence sources because all of the threat intelligence sources it checks are open source. They're free. Like anybody can use them. Uh, and then implement a cleaner layout and printout. I also would have a word of warning if anybody ends up wanting to use Selenium to automate this kind of thing. Like give the websites a break and don't throw too much information at them. Like A, it might look like a DDoS attack or DOS attack or something. And then B, it's just like not nice to the website user. So I was only using like small PCAPs, but if somebody actually tried to run a full like network capture for a day or something through that, it would like obliterate small website servers. And then does anybody have any questions about this? Sweet. All right. We're all good here, Odin.
Great. Yeah. Well, thank you, Evan. Nice work. Yeah. So yeah, other than that, I didn't really have anything else planned, so we can end it early unless anybody. I know I did announce that contest like a couple of weeks ago, but it probably like with break and everything, I don't know if like a lot of people had a chance to look at that, but if anyone did and if they want to share the rules that they create, like the rule that they created for Suricata, we can if anybody's has like a rule that they created, then if you'd like to show it, you could do that now. We also have a question from David for you, Evan. He was asking like what version of Python were you using?
Yeah, I was using Python 3 for this. It was like kind of funky. That was one of the many things that I like ran into while trying to figure out Python and kind of learn it for my first time was running into all the different like tutorials online and stuff. And half of them are for Python 2, and then half of them are for Python 3. And then like if you try to do it, just like break your whole program.
Cool, yeah. So yeah, did anybody have like did anyone want to share like the rules or did anyone create any?
Nobody here did currently, but I think I've got like a couple people that will still be wanting to email them in.
Yeah, I was thinking of extending the deadline probably until January 1st. I'll send a follow-up email so that just gives everyone time like during the break if they wanted to take a look at it. And then like the next week, like in January, like the beginning of January, we can like judge all of the rules and pick the winning rules and maybe the next meeting if people want to share they're welcome to. Other than that, so this is the last Malware Club meeting of the semester. So then, like, we'll resume January 12th for the next semester. And we're still figuring out, like, what kind of topics we want to do, but we definitely want to do some more advanced topics, probably looking more like, so far we've just stayed looking at, like, mostly just like, more introductory topics to malware because we've had people from like a variety of different backgrounds. So we're going to want, but right now, like a lot of people now are have like more of a reverse engineering background. So we're going to like step it up a little bit and look at like actually like reversing malware in more detail. So probably using like some disassemblers, like IDA. We might look at like some others like Ghidra or like some debuggers. And yeah, just more detail, like looking at different types of malware, like looking at like the assembly code. We might also look at like some .NET malware, but we'll figure that out as we go along. But it should be like very interesting like next semester. So yeah, it for this semester. And oh, David, you said did we lose audio? Can you hear me? Okay, everybody. Oh, okay, I'm back. All right, all right. So yeah, that's it for the semester. But thank you everybody for attending, and we'll see you next semester.
Have a good break.